Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so we are at the end of the lecture for topic of probability, 3 of 3 here now. So in this video, we are going to look at both of conditional probability and independent events. So conditional probability is that event will occur given that another event has already occurred. Okay, so probability of B considered as what we call event that already occurred, and A will occur. Okay, so probability of A given B. So A and B are two events such that probability of A is all given here. So find probability of A union intersect B and also probability of A given B. Okay, so for this one here, it is probability of A union B plus probability of A plus probability of B minus probability of A intersect B. So this is here. Okay, so then bring these two to the left side and times with negative, so it gives you probability of A plus probability of B minus probability of A union B equal to the probability of, I think that I rewrite all this. Okay, so then bring these two to the left side, become negative and multiply with negative, so then probability of A intersect B equal to the probability of A plus probability of B minus probability of A union B. Okay, so then probability of A equal to 1 over 3 plus probability of B 1 over 4 minus probability of A union B is 1 over 2. So then, make it all equal to 12. So 3 times 4 equal to 12. 3 times 4 equal to 12. So 1 times 4, and this is 4 times 3 and 2 times 6. So 4 plus 3 equal to 6. 4 plus 3 equal to 7. Minus 6 is 1 over 12. And then probability of A given B. For this one here is a probability of A intersect B divided by the probability of B. And it is equal to A intersect B. A intersect B, we have found it first one here. It is 1 over 12. Probability of A intersect B is 1 over 12. So then probability of A intersect B is 1 over 12 divided by probability of B, 1 over 4. Okay, so bring us here, become 4 over 1. So 4 divided by 12 equal to 1 over 3. And for C, it is probability of B intersect A divided by probability of A. Okay, probability of B intersect A or A intersect B is 2, they are equal. Okay, you may use this 1 over 12. 1 over 12 divided by probability of A, which is 1 over 3. So here become 3 over 1. So 3 divided by 12 is 1 over 4. Okay. So example 2. 30 professors out of 100 who are examined were found to be overweight. 10 of them has high blood pressure. Only 4 professors who were not overweight, okay, not overweight, that had high blood pressure. So find probability of all this. Okay. Okay, class. To solve this question, let's extract. Okay, let's extract or take all this information, 30 professors of 100, then for all this, and we put them all the informations in one simple table. Okay. One here and here. Okay. Okay. So then we divide it into weight and overweight W and not overweight or W complement, and then high blood pressure H and not high blood pressure H complement. So then, according to the question, 30 out of 100. So the total of professors is all 100, and 30 of them are found to be overweight. 30 of them is overweight. Okay. Only 10 of them have high blood pressure. 10 of the 30 has high blood pressure. Only 4 professors who were not overweight, okay, 4 professors who were not overweight, but then had high blood pressure. 4. Here. Okay, so we need to complete all this, we call box here with a value 1, 2, 3, 4, and 5. Okay, meaning we need to make some calculation, simple calculation. 10 plus something equal to 30, so 30 minus 10 equal to 20. So 100 minus 30, 17. 10 plus 4, 14. 70 minus 4 equal to 66. 66 plus 20 equal to 86. So to make sure that this table is correct, so 30 plus 70 equal to 100, it mentioned in the earliest in the question, the total of professors is 100. So 14 plus 86, 14 plus 86 is also equal to 100. If it's not, then you may find, please double check where is the number, we call the value which is not, we call the correct one, and make your own correction. Okay, so now, question A, find the probability of professors who are overweight and high blood pressure. Okay, so find the probability that the professor is overweight if he had a blood pressure. So, according to the question, find the probability that the professor is overweight if he had a high blood pressure, meaning high blood pressure is already occurred, but then this will occur. Okay, so then it is probability of W intersect with high blood pressure divided by the probability of high blood pressure. Okay, intersection between W and H, which is 10 over 100 here. 10 over 100. Divide by probability of high blood pressure, 14. Okay, 14 over 100. So simplify this, it's going to give you 14 over 10 or 5/7. Okay, so 10/100 times print this above here and come out with 100/14. Okay, 100 divided by 100, so 10/14, 5/7. And question B, the probability of, what's the question just now? Find the probability that professor will not have high blood pressure, if he is overweight. So means that has no high blood pressure, but then he is overweight, so probability of H complement intersect with overweight divided by the probability of overweight. Okay, so this is H complement intersect with W. H complement intersect with W. Okay, H complement and W, which is 20 over 100 divided by probability of overweight 30/100. So again, brings up here, switch the position upside down, something like this. 20/100 times with 100 divided by 30. Okay, so 100 divided by 100, then come out with 2/3. Okay, the probability rule for conditional event given here. Okay, so probability of A intersect B equal to probability of B multiplied with the probability of A given B. So actually that this equation is actually derived until we make a adjustment from this equation. So multiply with probability of B and probability of B here. Cross multiply. Okay. Okay, now Harry travels to work by either route A or route B. The probability that he chose route A is 1/4. The probability that he late for work if chooses route A is 2/3, and all this. Okay, you read out by yourself. Okay, so refer to the questions, and now we are going to come up with what we call a probability tree diagram. Okay, so if I read the question, Harry travels to work by either route A or route B. So it's either route A or B. Okay, the probability that he chooses route A is 1/4. Okay, so if mentioned here, one of the stand here is 1/4, so the other one it is 3/4. Find the probability that he is late for work. Okay, if he late for work and L complement means that he is not late for work. Same goes to this one here. If he late for work, if we use the route B, and another one is not late. Okay, the probability that he is late for work if choose route A, if he late is 2/3. So another one here is 1/3. So 2/3 plus 1/3 equal to 3/3 or equal to 1. And the probability that he is late for work if he chooses route B is 1/3. So here is 2/3. So what is the probability that he is late for work on a particular date? So if we call probability that he is coming late for a particular day is, okay, means that for question A, what is the probability that he is late for work on a particular day? Okay, so means that we focusing, okay, this is the starting point. We have a choice of route A and end up with L here, and also using route B and end up with a late here for question A. So it is a 1 over 4 multiplied with 2 over 3. Okay, 1 over 4 multiplied with 2 over 3 plus with, okay, if you use root A and he is late, plus with if we use root B and if he is late, so then it is 3 over 4 multiplied with 1 over 3. Okay, so you recall, press the calculator, or you make it recall, count it manually. Okay, so if you count it manually, it's okay, but then use a calculator and it give you 5 over 12. Okay, and question B, what's the question B then? Given that he is not late for work. Okay, before that, for question B, given that he is not late for work, what is the probability that he choose route B? Given that he is not late for work. Okay, given that he is not late for work. So late for work, he is not late for work is something that already occurred. Okay, so what is the probability that he chose the root of B? This is future. That might be if he used the root B, but this one is not late for sure. Okay, so means that is a probability of B intersect with not late divided by the probability of not getting late. Okay, so class. Okay, class. For this question, probability of B using root B and is intersect with not late, B multiplied with 2 over 3 or not getting late. But then for this one here now, okay, for this we need to consider both of using root A and L complement here, plus with using root B and end up with L complement. So probability of for probability of L complement equal to 1 over 4 plus times with 1 over 3 plus with probability of using root B, which is 3 over 4 and multiply with not late here L complement 2 over 3. Okay, so then here now it is over 12, 1 times 1 equal to 1 plus 3 times 2 equal to 6, which is 7 over 12. So it is now probability of B intersect with the late, B intersect with not late, which is 3 over 4 times 2 over 3 divided by 7 over 12. Okay, so use a calculator, try to get answers here is 6 over 7. Okay. Independent events. If A and B are independent events, it means that outcome of one does not affect the outcome of one other. Then probability of A given B is probability of A, and probability of B given A equal to probability of B. Means that the event of A has nothing to do with B, does not affect at all. Okay. Okay, so probability of A intersect B is simply given that. Okay. Okay, so please try to remember all this. Example 4. Suppose two events A and B are independent. Given probability of A 0.4 and probability of B 0.25. Find probability of A intersect B. Okay, so to answer these two questions here now, for A, probability of A intersect with B equal to probability of A times probability of B, which is 0.4 times 0.25 equal to 0.1. Okay, and here property of A union B equal to probability of A plus probability of B minus probability of A intersect B. Okay, the thing is, for this one here now, it is probability of A plus probability of B minus probability of A multiplied with probability of B, independent. Okay, so then probability of A equal to 0.4 plus 0.25 minus this one, we can get here 0.1, and the total is 0.55. Okay. A, B, and C are three events such that A and B are independent. A and C are mutually exclusive. So, given all the values of probability of A, B, probability of A, probability of B, probability of C, and given them. So, find probability of A union B of that. Okay, so for question A and B and C, okay. For question A, probability of A union B equal to, again, probability of A plus probability of B minus probability of A intersect B. Okay, mention in the question that A and B are independent, meaning this is probability of A multiplied with probability of B. Okay, so what is the value of probability of A given in the question then? 0.4. 0.4, 0.2, okay, and then 0.4 plus 0.2 minus the multiplication of 0.4 times 0.2, okay, so 0.4 plus 0.2 minus 0.08, I think so. It is 0.52. Okay. Question B, probability of C given B. Okay, and between C and B is probability of C intersect B divided by probability of B. So it is probability of C intersect B, given in the question that B intersect B, C intersect B is 0.1 divided by probability of B is 0.2. It is 1 over 2 or 0.5. This one, probability of C intersect B. Please refer to the question. Recall given here. Given in the question is probability of B intersect C. Okay. It's all the same, so we can use this to represent C intersect B here. Then C, the probability of C given A complement. So it means that the probability of C intersect with A complement divided by the probability of A complement. Well, given in the question that the probability of A, in the question given probability of A equal to 0.4 here. So then the probability of A complement equal to 1 minus 0.4, which is 0.6. Okay. So probability of C intersect with the A complement. Okay, so from the tree diagram, not from the Venn diagram here, let's say this is an event of A, event of B, and event of C. Okay, so this is area of the probability of C intersect with A complement. Okay, then it is equal to 0.3 divided by 0.6, which is equal to 1 over 2 or 0.5. Okay. A puzzle is given to the students Aziz and Bong. From past experience, know that probably Aziz and Bong will get the correct solution 0.65 and 0.6 respectively. If they attempt to solve the puzzle without consulting each other, find the probability that the puzzle will solve correctly by both of them. Only one of them will get correct solution. So from here, it's known that a puzzle is given to Aziz and Bong. So Aziz and Bong, the probability that Aziz and Bong will get correct solution is 0.65 and 0.6. Okay, so probability of Aziz getting correctly is 0.65. So if I list down here, probability of Aziz will not get correctly equal to 0.35. And the probability of Bong getting correct is 0.6. So the probability of Bong getting incorrect is 0.4. So then the probability of A, Aziz and Bong get correctly equal to probability of A 0.65 and 0.6, which is equal to 0.39. Okay. And for question A, question B, probability of only one of them will get correct solution, meaning that the probability of if Aziz get correctly and Bong get incorrect, or whether Aziz get incorrect intersect with Bong get correctly. Okay, so this one here now, the probability of A intersect with multiplied with probability of B complement plus with probability of A complement times with probability of B. Okay, so this here now, probability of Aziz get correctly 0.65. Probability of B get incorrect, B complement 0.4. Plus with probability of Aziz get incorrect is 0.35 times with probability of Bong get all correct, which is 0.6. So simplify these two, get the answers, it gives you 0.47. Okay, so exercise as usual, I'm not going to solve in this video. I'll let all of you to try the question by yourself, and given provided an answer here is 1 over 7. Okay, so try this question. Please refer to some of the reference book. Okay, so it helps you to understand the process of solving this. Okay, for this question, I'll give you the final answers given then. Question A1, which is 3 over 20, the final answer here 3 over 20, and mathematics only, A2 equal to 3 over 10. Then question B, the students at the random determine whether this event is taken is independent of the event taken in biology. Okay, the two events are independent. Okay, so that is the final answer for this question. So that's all for today, and I do hope that this video helps you, and please do continue video tutorial and PSPN. Good luck for the next coming PSPN examination. That's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.